All right, so I started the video. So we have a special guest at today's meeting. Brendan Burns is going to demonstrate ACI, which is a cool feature that is part of Azure now, as of I guess a week or so ago. And then after the presentation, we can see if there's any other agenda items that folks want to talk about. But why don't we let Brendan get started?
Cool, thanks. Hopefully this is interesting because it directly relates to scheduling. All right, so, and I'm going to do it again in a community meeting, so hopefully we'll catch more people there too. So Azure Container Instances. I should share my screen. There you go. All right, can people see my screen now? Yes, maybe.
Hey, I have a quick question. Is the audio level low on anyone, Brendan's audio level low for anyone else on the call, or is it just me?
Oh, is that better?
Yeah, that's definitely better.
Okay. I've had complaints about this headset before. I will hold the microphone right next to my mouth.
Yeah, that's much better. Thanks.
Cool. Can you see my screen?
Yes.
Okay, cool. So what I want to show over here is I'm gonna go to queue control get nodes. And so what I have here is a very lonely Kubernetes cluster that just has a master. Obviously, scheduling is disabled on the master. And so what I'm going to show now is, so I should take a step back. Azure Container Instances allows you to run individual containers without VM infrastructure. And so what I'm going to demonstrate is how we link this up to Kubernetes. So I have an empty Kubernetes cluster here without any nodes, just a master. And then I'm going to run the connector. And what the connector is doing is it's basically bridging between the Azure Container Instances API and the Kubernetes API. And so what we'll see now, if we go over here and we list nodes again, is we now have a new node, a new virtual node, if you will, that's ready, and it is it's only 13 seconds old. Now this node has a because I don't think that people want to schedule things onto Azure Container Instances without understanding that that's what they're doing, although it's an interesting discussion point. This node has a taint. And so if we do get nodes -o, let's see if we can scroll up and find it. It's the master. There we go. So you can see here it has this taint, so that in general pods won't land on it. But of course you can actually schedule something that has a toleration for that taint, and so we can actually say kube control F. So we can create a container that accepts that toleration, and if we do kube control get pods, you can see that it's pending. And if we're lucky, we'll see it. I'm looking over here, and it's just going to give me hardware. Well, clearly I need. I just ran through this demo just before I. I just ran through this demo just before I did it.
It's the nature of demos.
It is the nature of demos. No, don't create. Well, all right. I'm gonna stop the demo. But the basic notion is that it actually creates the container over in ACI, and I swear 5 minutes ago this worked. But but it creates the container over an ACI and then starts populating the information back into Kubernetes. So that pod goes running, and you can then see its information inside of the Kubernetes API.
What node capacity was being reported, or node allocatable is being reported for that node?
It reports really large capacity, basically.
Right. Okay. Yeah, I mean, that's what I was assuming.
It reports like 100 cores or something like that. I can't remember exactly what I said, but like there is quota in ACI. So there's a quota to how many containers you can run. And so we could populate that information in. But actually, that's one of the interesting questions, basically, which is if this thing effectively has infinite capacity, is modeling it as a virtual node even the right thing to do? Right? It's certainly the easy. Sorry, I should hold my microphone up. It certainly is the easiest thing to do, but is it the right thing to do? And then, of course, like I don't model any kind of affinity right now, and so the scheduler by default is going to view it as a node. Is going to view that node as a failure zone. Is going to try and avoid placing multiple containers onto that theoretic failure zone. But of course, actually, ACI isn't really a node, and so putting multiple containers on it actually doesn't imply anything about failure.
But the pod also have explicit affinity or anti-affinity as well. And for example, I may create another node saying that I don't want this. I may create another pod saying that I don't want this to land on the same node that is running my other pod. And if this is seen as a single node, then my second pod will never schedule. So there are
right, exactly. And so there's a degree to which I think the interesting question effectively is how much affinity do we push into the ACI API versus how much do we push into the Kubernetes API? And is it even the case that we should try and use the same scheduler, right? I mean, maybe the truth is that we shouldn't use the same scheduler, and if you want to run stuff, from Kubernetes into this thing, you should actually instead of having this connector, we'll just actually have effectively a Kubernetes scheduler that is responsible. So instead of having a toleration, effectively, we'll write a complete scheduler that's responsible for scheduling things and understands ACI. I think that this is the goal of bringing this up at the meeting effectively is because I don't think we've explored this before. This is the brand new piece of cloud infrastructure that no one has really ever built before. And as such, it's very intentionally intended to be a low-level building block that orchestrators build on top of. We have absolutely no plans to evolve this thing into its own orchestrator. And so the question that I effectively wanted to have the discussion around is, if we believe, and I actually believe, that every cloud is going to have something that looks an awful lot like this sometime in the 1 to 2 year time frame, how is Kubernetes supposed to manage those things? Right. Given that Kubernetes was really originally intended to manage machines, and this is kind of moving you into a post-machine world.
Yeah, although, I mean, you could argue that most people are running Kubernetes on virtual machines today. And so, like, if you ask for spreading your pods across nodes, those nodes could all be on the same physical machine, and you actually don't get any failure tolerance. Right. So, like the existing infrastructure that most people are using is already virtualized, and
we already
have a similar problem today. Sorry, go ahead.
But we do surface that, right? Like we surface failure zones as labels on machines, and the scheduler actually tries to avoid putting things into the same failure zone.
Well, we schedule the zones. We have like a zone and I think region.
No. There's actually the notion of like a node failure. There's a node failure notion.
So I thought that we have, I guess I'm wrong, but I thought we have a node, like the node name, which is basically like whatever the virtual machine name is that the cloud provider gives us. And so you can spread your pods across those virtual nodes, but those virtual nodes might all be on the same physical node.
You can, there's failure domain zone, I guess.
Right.
Which
there's definitely zone and region, but yeah. I think that
not machine.
Yeah, that's true. Yeah, the host name there is like a virtual machine name, basically.
Yeah. No, it's true. You're right. So we don't surface, but we could, in theory, surface effectively rack.
You could, right. And I think part of it is like how much of this information do cloud providers actually want to give to like end users? Like, and also not just because they don't want to reveal details of their internal infrastructure, but also because it limits the flexibility of what they can do behind the scenes, like live migration or whatever. You know, I mean, you know all the issues. So like I think it's yeah.
I will also say that part of the goal of the cloud provider, certainly when we do this in Azure, and I think the same thing is true in GKE, we explicitly try and spread the machines, right? We explicitly tell the infrastructure, like, hey, please try not to co-locate these things,
right?
You know, with grouping primitives that try and avoid landing multiple machines on the same. So there's already this secondary scheduler going on.
Right. Yeah. Exactly. And I mean, I assume that the managed instance groups do the same thing in GCE. I'm not 100% sure, but yes, but that's exactly what the issue is like how much you have like two level scheduling going on here, and how much information you expose from the lower level, or do you try to combine the scheduling, which that seems hard and maybe undesirable, but yes.
And I think the thing here is, though, it introduces even a deeper thing, which is that like the node is vanishing at some level, and yet we still model nodes. And so like if we want nodes to, and we believe that pods land on nodes at some level, right? And if that is kind of going away, like what does that mean?
Well, yeah, and it's a pretty big change to get rid of nodes. I mean, so can people, when people use ACI, can they log into any VM, like the VMs that?
No.
There's nothing, they can't.
No.
So when you do kube control, like to look at the logs, what do you see?
You get the logs. I mean, you get just like you would get kube control.
So you
logs.
can get the logs, but you don't obviously get like the system level logs. You don't
get system level logs. You only get the application level logs.
Yeah.
I mean, of course, obviously, like you could run SSH in a container, run it on ACI, log into SSH, get a terminal, mess around, you know, but you're inside the container.
Right. And the VMs that are backing the virtual node are using, you mentioned some kind of hypervisor-based isolation. I'm sorry, the containers, the
containers are using hypervisor-based isolation to prevent them from breaking out multi-tenancy. But you don't see the VMs, right? Like as an end user, you don't see them anywhere. Not in your subscription. You don't pay for them. You pay for the container. You don't pay for VMs. You don't pay.
Right.
And can one of these virtual nodes span multiple physical machines?
Yeah, that's the thing, is like they do span multiple physical machines.
Yeah.
Right.
So,
like there is no physical machine. From the user perspective, there is no physical machine.
Right. But basically we are sort of like moving some of the responsibilities of Kubernetes, like for example, fault tolerance, part of the fault tolerance, and spreading and some of that to a different abstraction layer, which is the ACI right now.
And I think that's exactly the question, right? Is that's exactly what we're doing?
We have to decide basically. So
sorry, what?
We have to decide about whether we want to go this direction or not, and also we have to decide whether we want to have another scheduler versus having another policy on the existing scheduler.
Right. So like I think that the first question effectively is that, like, does Kubernetes core scheduler even want to know about this and understand this? And if the answer there is no, then the rest of it is obvious. The rest of it is like, okay, great, we'll implement our own scheduler. If you want to use ACI with Kubernetes, you're going to have to mark things to use the custom ACI scheduler, and then the ACI scheduler will take care of it, and everything else is fine. And otherwise, it'll be ignored by the main scheduler.
But how is this other scheduler different? Like, are you saying like it would understand the layout of the contain, like it would understand the layout of the lower level things that these containers are being scheduled onto, or right? So the node concept is pretty baked into the Kubernetes API. So I'm just trying to figure out how this second scheduler would work.
Right. So I mean, but the node is actually not that baked in, actually, when you think about it. Like it's baked pretty deep into the scheduler, but it's not very deep in anything else.
Mm-hmm.
Right. Like it's just a string effectively for a pod, and then everything else doesn't even have it. Right.
Yeah, I guess that's true.
And there's some details like kube control exec and kube control logs kind of like use it to go find and make and wire things up. But you can you could have a virtual kubelet that knew what it was doing, that like did the right things to make to wire logs and exec up. And so the scheduler would be basically be the same thing as this connector, right? Which is it would say, oh, hey, look, there's a pod over there. It's not scheduled. It doesn't have a node name associated with it. Therefore, I need to go and take that pod, take its annotations. And of course, if we went down this road, you'd have potentially special annotations for ACI. And then I'm going to go create the ACI containers that'll map that. And then I'm going to pump, like in this world, the kubelet doesn't exist. Like there is no kubelet for ACI, basically. And so the connector is the thing that's pumping all the data back into the API server to make the API server understand that there's a pod there.
So you need something more than, sorry, go ahead.
And so the question effectively is like, do we think that there's enough of an interface layer between the pod and whatnot that we can use, that we can refactor the existing scheduler? Like, because that's what's happening right now is the existing scheduler is just saying like, I have space over there, I'm going to go do it. Or do we believe that like there just isn't, and like we should just implement a separate scheduler?
Well, I mean, so the separate scheduler, you're saying it would also incorporate the functionality of the ACI connector?
Yeah, I mean, something has to play that role. I mean, it could be two different services.
Yeah, I mean, that's what I'm thinking. Like maybe that could be a separate controller or something that sees that the node name has been set to ACI.
Yeah, and that's probably what was going on. And honestly, like in the connector, that's more or less what's going on. Is there's a bunch of different threads, and one of the threads is just looking for containers. It's basically just being the kubelet. It's looking for containers that have been scheduled to this virtual ACI node, and then it goes and creates them in ACI.
Right. Yeah. I mean, it seems like that it makes sense to keep that out of the scheduler, especially because other cloud providers in the future, in theory, might have something like this, and so it would be cloud provider specific, and so ideally the scheduler part would work for all of the cloud providers that offer this.
Right, exactly. And I think the question just becomes like, do we believe that the notion of node is baked so deeply into the scheduler, the existing scheduler, that it's not worth trying to
but I still don't understand exactly what this other scheduler would do. I mean, we talked about like it would set the node name to ACI or something. That's what we were using in our hypothetical example here. But in that case, like it's really just the same as our existing scheduler. And so operating the way your prototype thing here, is doing. And so how, and like if we surface labels, if we surface like topology information from the underlying hardware up or virtual machines up to the scheduler, I guess that's the difference, right? Is that it had have some understanding of the topology that's backing this large virtual node. Is that how
that's part of it? And the other part of it is it would have different soft priorities, right? Like it's not going to try and spread across nodes because it just doesn't make any sense to spread across nodes.
So why don't we have just a set of different predicates and priorities and have a different policy for the existing scheduler?
Yeah, maybe that would work.
Right. So like one of the options is actually like right now the policies and predicates are hard coded in a command line flag. One option would be to say is that not true? They used to be.
Yeah, you can set it using a file on the master, and Bobby has.
Okay, well, sorry. It's set constant. It's a constant for the scheduler. It's not like as a pod I can opt into different sets of settings, right?
Actually, you can.
Per pod.
One of my
per pod. He's saying you can't change it per pod. Your thing lets you change it for one instance of the scheduler.
Right.
Yeah.
Right. And so we could do that, right? I mean, we could say like, hey, we're going to run two different instances of the same scheduler with different configurations. And that's maybe a middle ground.
Right.
Like I think ideally you say it per pod, right? Like ideally when I know that I want to like sort of that like this is a flexible pod versus a not flexible pod, or I mean, because ideally this is like burst. Like I would love to be able to set up Jenkins to target this thing with minimal effort on the part of the user.
But I mean, like I think you said at the beginning, you just set the scheduler name in the pod spec, and then if you run two separate schedulers, it's pretty transparent. So that would be.
I mean, and that's not bad. If we think that that's the right approach, that's not bad.
That might be the right thing to do. But yeah, it's interesting to think about whether the only change you would need initially is just take the existing scheduler and just choose different policies, like disable spreading or something like that. Because that would obviously be the simplest path forward.
Yeah. Yeah. No, that's a good idea. I will, and that's in some ways this. I mean, there's no difference between that and using a taint or a toleration. Because
exactly.
You have to set a toleration on the pod. And you could just set a scheduler on the pod.
Yeah. But I guess the question is like, what other functionality would you want in the scheduler? Or maybe the idea is that you then push some of the scheduling policies into the controller that is connecting Kubernetes to the ACI thing. So like the spreading policy maybe would be implemented there instead of in the Kubernetes scheduler.
I think that's what you'd want to do, because that's the thing that actually understands the infrastructure that's below it, potentially. Especially in the sort of world that you're talking about, where like there's one scheduler potentially and multiple cloud implementations. So.
Yeah, that makes sense. I mean, yes, and if the user wanted to have some control over what that controller was doing, like how it was laying things out in the underlying infrastructure, you could use annotations or something like that.
Yeah, I mean, the hope would be you just use the existing Kubernetes affinities for doing that kind of stuff. Already.
That's true. Yeah, maybe you don't. Yeah, you probably don't need the semantics would probably be similar, so maybe you wouldn't need something new. That's true.
Anyway, just stuff to think about. Anyways, we're not. It's all very experimental at this point, as you can tell from the demo not working.
Well, no, but it's definitely very cool. I think the
demo works most of the time. So if I'd recommend checking it out.
Does anyone else Bobby and I have been talking a lot. Do any of the other folks on the VC have any questions or comments about this? Well, apparently not. But
I'm going to do it at a community meeting on Thursday, and I'm going to make darn certain that the demo works on Thursday.
That's cool. This Thursday?
This Thursday, I think. Yeah.
Okay. Cool. So. Yeah, and I guess people. There's obviously more people on the mailing list than.
I'll send some notes from this.
But
the different paths forward to the mailing list.
Yeah, that would be cool. All right.
Well, so much for taking the time and listening and all that.
Yeah, thanks, Brendan. You're welcome to stick around or leave. It's up to you.
Oh, I got to run. I got a meeting.
No, thanks so much for doing that demo. It's cool.
All right. Well, hopefully it'll work
good to see you.
All right. Bye.
Bye. So does anybody have any other stuff they want to talk about? The one thing I want to talk about was unfortunately potentially changing the meeting time again. So before we do that, was there any other agenda items?
Just one thing I wanted to talk about. Although it's not on the agenda, I had sent an email regarding upgrade issue between 1.6 and 1.7. I'm not sure you guys got a chance to look at that.
Yeah, I'm sorry, I didn't have a chance to look at that. I'll look at it today.
I'm not sure whether we really want to take care of that in 1.7. I mean, I think it would be good, but.
Do you want to explain it briefly, or is it like now that you brought it up, people might be wondering what the issue is.
Yeah. I mean, whenever we have this preferred scheduling with pod anti-affinity, the topology key can be empty. And I think out of 4, that is the only one. For that, we allow empty topology key. And that was true up to 1.6. In 1.7, we made one change. Also, I made that change, and I think David, you had created that issue. But when I looked at that change, somehow what we did, whenever that affinity in annotation feature is disabled, we check that topology key is never empty for any of the 4 cases. And because of that, what's happening when people are upgrading from 1.6 to 1.7? And when the topology key is empty, it's failing in 1.7 because now it does not allow empty topology key. And that is kind of regression also. So That is the issue basically.
I see. But what were you saying about, like, I think I understood that, but like you were saying something about if they've disabled the feature?
Yeah. Actually, also like in 1.8, we have completely removed that code. You remember like we had feature gate for affinity in annotation in
Right.
1.7. So what we did, like we had a check in 1.7, like whenever that feature is disabled, affinity in annotation, we always check the topology key should not be empty. And by default, that feature is disabled in 1.7, and that's why that issue is happening.
I see. Yeah. So, and the feature, but so the feature was, sorry, which feature was it? What feature gate was it?
Affinity in annotation. Affinity in annotations.
Oh, so this is just talking about what you have set in an annotation, not what's set in the pod.
No, but the problem happens when you set that in pod also. I mean pod fields also. Pod spec fields, I mean. Basically, it's simple. We have like preferred I forgot the preferred scheduling, right? Soft anti-affinity. We allow empty topology key, but somehow in 1.7 we have a check that does not allow that.
In 1.7, we have a check that does not. I remember that we didn't want to implement that. I think because of performance reasons, right? That was the reason why we don't allow empty topology key except for anti-affinity.
But in 1.7, what we did for even for anti-affinity and that soft anti-affinity, that check is I mean we don't allow empty topology key. Only if that affinity in annotation feature is disabled. But unfortunately, that feature is by default disabled in 1.7.
Right.
Yeah.
Right, because we were trying to get rid of it. No, I understand. Like that was the.
When I look at that, I mean, I'm not sure like why we made that change, but somehow like now it feels wrong. But
so it seems it sounds like the right thing to do is so.
Just to take off that check. I mean, even I sent a PR already to 1.7 branch. If you want,
Yeah, I mean, so if I understand, so I didn't look at the PR, but like it sounds like you would take out that check.
Yeah.
When you set it in the annotation, but you'd still have that check when you set it in the field, right?
Actually, if we take that check out for affinity in annotation disabled case, then it will work fine, because then the code is exactly same what we already have in 1.6 and what we have currently in 1.8 basically. So it will be parity. Just because of that check, like we are having that issue.
I see. So the check isn't protecting us from something that's unimplemented. Is that right? Like, I thought that the reason for the check was that we stopped supporting empty topology key for some of those, for the 3 cases.
Yeah. I think those 3 cases are still fine. I mean, those 3 cases don't have any issue, because even in 1.6 we did not allow empty topology key for the other 3 cases. So I'm not sure like what is your point? Because
I see. So you're saying that the only thing that changed was that one case we stopped allowing empty topology key.
Yeah, soft anti-affinity.
Soft anti-affinity, and we shouldn't have done that.
Yeah, right.
And you're sure that the scheduler does support empty topology key for soft anti-affinity?
Exactly, like we had that in 1.6 and we have that in 1.8. So I'm assuming we should have that in 1.7.
Okay.
Otherwise,
I mean, I can't remember. I can't remember. Wojtek was the main person who was working on that, and so I don't remember. But yeah, if it's not, if the check is not protecting us from something that's unimplemented, then it seems fine to get rid of the check, right?
Yeah, right now it seems fine. But I mean, if you guys could look at the PR, then I mean.
Sure, and we should make sure Wojtek also looks at it, because he's the one who was working on that most recently. But yeah, that sounds fine. Thanks for explaining.
Yeah, thank you.
does anyone else have anything else they want to talk about? So the one thing I want to talk about was Tim Sinclair has a conflict at this time, and some of the people, or at least I don't know, at least one person from the East Coast had a conflict at 1 hour later from now, and so what Tim and I found that we are both available at noon Pacific time on Thursdays. Would that work for people? I mean, obviously, I would send this out to the mailing list.
So you when you say noon, you mean 12 p.m., right? 12 p.m.
Yeah, 12 p.m.
EST.
Pacific time. I mean, PST or PDT. You know, we would change it, but yeah.
Okay, I think that would be 3 p.m.
Right.
EST. So I think that's fine with me. I'm not sure about others. Yeah.
How about with the other folks? Is there anyone who would not be able to attend at noon on Thursday? That would also make it a little bit earlier. I mean, we don't seem to ever get anyone from Europe attending this, but that way it would at least be a more reasonable hour. Also in Europe, it would be 9 p.m. It's not going to help the folks in Asia. There actually seems to be more interest in Asia for this SIG than in Europe, but you know, it would help the hypothetical people who don't attend from Europe, but could maybe. I don't know. All right, so nobody objected to that. I'll send out an email to the mailing list. We can see if anybody has an objection to that, and if not, I guess we can change it to noon on Thursday, starting 2 weeks from now. Anything else anybody wants to talk about?
Did we assign those approvers for the projects?
Oh yeah, that's a good point. So yeah, we didn't, like, I signed up for the ones that I have the bandwidth to be the approver for, but there's still a bunch that don't have approvers signed up. So we have to figure out what to do about that. Maybe I should send email to the mailing list, or you can do it. Like Bobby's talking about, like, that we have the spreadsheet for 1.8, and we introduced this idea of having approvers so that the person working on the PR would know, like, when they're done, basically, and it could merge. And like, I made myself the approver for a few of the things on the list, but like, I can't do all of them because I don't have time. And so there are still a bunch that don't have approvers. And so that is potentially a problem, because it means that we might get to the code freeze and nobody has the time to actually review it. So yeah, so I can send emails to the mailing list about that, see what we can do. I mean, it's possible that we just took on too much for 1.8 again, like in terms of review bandwidth. But hopefully we can find people for all of the features in the spreadsheet. Anything else folks want to talk about?
Since Avish is also here, I have a question with respect to kubectl drain. David, if you remember, we wanted to use no schedule taint for instead of unschedulable field, and there is an issue that, or there is a point that Avish has raised with respect to using no schedule taint. Do you think it's appropriate to talk about it now, or?
Sure. I haven't had time to read that issue, but you can, if you want to give the background on it, we can talk about it.
Sure. Avish, would you like to go ahead and talk about that?
Yeah, I mean, the issue is like, instead of using unschedulable field, we should use some no schedule taint for setting a node as unschedulable.
Right. Yeah, I remember that part.
Yeah, and I think Ravi wanted to work on that, and it seems the way he wanted to implement, I think his idea was, as far as there is any no schedule taint on that, his idea is the node should be unschedulable. Basically, his idea is he checks for, as far as there is any one no schedule taint, he sets the node, node is unschedulable. But what I suggested, I think we should not rely on that. because no scheduled taint is not exactly same as unschedulable, because as far as there are pods that could tolerate that no schedulable taint, those pods could still be scheduled.
Right.
So what my suggestion was, we should have some standard no schedulable taint, and we should ensure that no pod should be allowed to have that taint, so that we can exactly get the behavior what we have with unschedulable.
Well, yeah, I mean, I think that's a policy question of whether you want to allow people to tolerate the drain.
Yeah, but generally, like whenever, in case of drain, whenever we set unschedulable, I think except daemon sets, we don't allow any other pod to schedule, right? So that's why, like I was suggesting, as far as we have some standard, just one standard, no schedule taint, and if we have some policy that says no pod should have that taint, maybe except daemon sets, because anyway, daemon set could be scheduled because they have some sort of like everywhere taint, some like that. So I mean, my point was like we should not have some journal taint, no schedule taint that are already on the nodes to signal that node is unschedulable.
Because you don't want to allow pods to tolerate that.
Exactly, because what if by mistake there are new pods that are tolerating that taint, and then those pods could still be scheduled when the node is in the process of being drained.
Well, yeah, this is a problem. I mean, I don't know. It's kind of not great to have a taint that has special meaning. I mean, like if we could do this using the standard, like some kind of authorization mechanism, like or an emission controller or RBAC, like we have this as a related issue with dedicated nodes where we don't want to allow people to just set a toleration for a dedicated node taint because then they could use other people's dedicated nodes. And this sounds a lot like that, but I mean, one of the issues is that actually I think it comes up in both cases is that I think we have like a star toleration. Like I think there's some way to express that you tolerate all taints. I can't remember.
Yeah, you're right. Yeah,
and
right.
so that's going to be a problem. I mean, I guess whatever authorization scheme we use, like you would prohibit that in addition to prohibiting tolerating like the dedicated node taint or the drain taint. But maybe like my hope would be that these cases are similar enough, like the dedicated node scenario and the draining scenario. If like in one case you want to limit who can set the toleration, and in the other case you want to forbid the toleration completely. But that sounds similar enough that maybe we could use the same mechanism for it. On the other hand, I mean, I guess you could argue like if we aren't going to allow people to tolerate it, then maybe this is just a bad idea, right? Like maybe we're not going to be able to get rid of unschedulable like in the V1 API. Like we can probably get rid of it if we do it someday. Presumably we'll do a V2 API and we could get rid of it. But like we're not going to be able, because a lot of people are using it for their own purposes, you know. And so if we can't get rid of unschedulable in the near future, maybe it's not worth trying to represent the node drain using a taint. If this taint is going to be something that nobody is allowed to tolerate.
Only for that temporary part. I mean, only for as soon as the drain
Sure.
part, and whenever it comes back, we should remove that standard taint.
Sure, but I mean, like you're saying that you don't think that any pod should be allowed to tolerate this taint, and so, you know, I don't know if there's much value in doing this right now.
Yeah, exactly. I mean, if we want to stick with unschedulable flag, then obviously it doesn't make much sense.
Yeah. I mean, but I think the question is whether we really want to prohibit tolerating that taint. I mean, yeah, certainly for backward compatibility, you want the existing stuff But the existing stuff isn't going to be tolerating that taint anyway, except for that the one case that I would just mention, which is like the wild card.
Right.
And so that is something that will break right away. Like if people have replicas set like pod templates where they tolerate the wildcard toleration, then this draining will not work. And so that's pretty bad, actually. So maybe that's a reason why we shouldn't do this.
Okay.
Yeah.
Yeah,
So,
maybe
yeah.
we can more discuss it in the GITF issue. Like if you
Yeah,
want to.
we can discuss it. Maybe other people in the community
Yeah.
have thoughts and stuff. We can
Right.
discuss it more in the issue. But yeah, it sounds like maybe that wasn't such a great idea. Sorry, I think I was the one who suggested. I mean, it would be nice. I think we do. Like, we do eventually want to get rid of unschedulable. There's no reason we should need it if we have taints and tolerations, but there are some access control kind of permissions kind of issues with tolerations that's, yeah, like in this case and in the dedicated nodes case that we have to figure out.
Right. Yeah. Thanks.
All right. Yeah. Thanks for bringing that up.
Thanks.
I hadn't had time to look into that one either. Anything else people want to talk about? All right, I guess we're done for today. People have stuff they want to talk about next time, just send email to the mailing list or stuff they want to follow up from today. All right, thanks everyone.